Generics can be challenging, confusing, and intimidating at first, and it might seem difficult to find a use case for them, right? But don't worry. In this tutorial, we're gonna effortlessly master this topic. Also, by the end of the video, I prepared a quiz which will help you to ensure that you understood the concept correctly. With that being said, let's jump straight to it. For starters, why do you need to know about generics? Well, generics make your code more flexible and reusable, which reduces the number of lines of code. As they say, less lines, less bugs, which is always a good thing. Okay, now we know why we need generics. How about we skip this boring part with the definition and we'll jump straight to the practical examples, and I will explain the details along the way. I don't think you'll mind. So let's switch gears. Okay, let's assume that you need to implement a max function which returns maximum from two values. Let's implement it. Function has been implemented, now let's run it. So run main.go. Okay, function works as expected. But all of a sudden, the requirements has changed, and now we need to implement the same logic, but as well for types float 64 and string. We can't reuse this function anymore, and we have to create similar functions, but for different types. And the logic will remain the same, and as far as Golang doesn't provide you overloading, we have to implement new names for these functions also. Let's do it. Okay, functions has been implemented. Let's test them out. I also would like to rename the first function with int because now it works only for ints. Okay, and now we need to specify the right values. Okay, let's test if it works. Everything works as expected. But as you can see, we repeated the same code 3 times, which is not very nice. And here generics come into place, and we can replace all of those functions by just one single function. We're gonna call it max. And here at first place, we gotta specify our constraints. So we use t as a type for our constraint, can be any other name, so basically the name for our generic type. And then we will list the set of types with which we would like to work. So I would like to work with int, specify or parameters to add more types. I also would like to work with string, and I also would like to work with float 64. Now I gotta add parameters and return parameter also. So parameter is gonna be the same, a and b, but now we'll specify this generic type, which can be int, string, or float 64. And the same type we would like to return. And implementation can be the same. We can just copy and paste it over here. And now we no longer need these 3 functions and simply delete them. So that we just get one single nice function. Let's test it. As you can see, it works as expected. But let's say we've got new requirements and we need to implement min function now. So we just copy this guy, paste here, write min, change the operator to smaller, and now we're ready to work with this function. Let's run it. We see that it worked as expected. But not nice thing that we had to repeat all of those constraints again. To get rid of it, we can create an interface and give it a name, so for instance ordered, and we can list the set of types over here without of t. And here we can, instead of this, use just ordered type that we just created. Let's run it. It works as expected. To go even further, what we can do, we can import ordered from the package that was added in the latest version of Go, CMP, which stands for compare. If we'll go inside, we can see that is almost the same what I implemented, but here much more types listed. And also they have this weird tilde sign, to which we'll come back in a second. Let's just make sure that it works. And it works as expected, so it's nice. Alrighty, so let's learn what this tilde operator mean. Let's move back as we had. Yeah, we had this order. Okay, to understand why do we need this tilde operator, we'll try to create our own type. And let's create two variables for this type. Types were created, and now let's try to use them. As you can see, we can't work with this type, and our compiler suggests to us that possibly we miss tilde, because tilde allows us to work with underlying types. So if we create some type with a string or any other type that's listed here, we won't be able to work with them unless we add this tilde sign. So now I added tilde to string, and we are able to work with strings. So I'll go ahead and add the same for other parameters. Okay, so now we can work with all of those types as well as underlying types if somebody will want to create his own. And to don't write it again and again, as I mentioned, we can use just ordered interface from compare package. And it contains all of those possible types, which is nice. Already we learned how we can use generics for simple types, but how about data structures? How we can apply generics there? Let's have a look. So let's assume that we would like to implement a function which allows us to find an index inside of the slice for some target element. Let's implement this function. We got to iterate through all of the elements and find the target first. If we have found the target, we would like to return its index. If we haven't found, then we would like to return -1. Alrighty, let's test it out. Let's run it. Okay, we see that it works as expected, and we found our index for value 20. But let's say again, requirements has changed and we would like to implement it for float value. Okay, so we gotta implement the same thing again. Very tedious process. Alrighty, we've done it. Let's test it. With int it work. Let's add also float. Okay, it works as expected also. Very nice. But again, we implemented the same logic twice. To not do that, we can use generics. Let me kill this guy. Let me remove this redundant naming in the function. And we'll define the constraint with keyword comparable. I will come back to it in a second. Okay, what this comparable allows us? It allows us to perform this equal or not equal comparisons, and it's defined in the keywords of the Golang, but it works only with the comparable types. for instance, booleans, numbers, strings, pointers, channels, arrays of comparable types also. So for instance, with array of comparable type, which is int and float, it gonna work. But if your type, for instance, your struct has inside of it another array, then it won't work. Let's have a look at on practice. So firstly, we can make sure that it actually works. Okay, let's run it again. We see the same result, so it works as expected. Now let's add one more type, which is struct. For instance, we're gonna call it person. At first, it will have only one property, which is age. Let's see if it works. Yeah, and it works. We can use array of structs also, or sorry, slice of structs. But let's say we would like to add inside of the person some slice, which will, I don't know, mean his family. We see immediately the compiler provides us an error that it doesn't satisfy with comparable compiler. It only will work if it's an array. If it's an array, okay, doesn't allow to work with it, but let's say, yeah, he would like to store, for instance, indexes of his family relatives, then it's gonna work. I think that's it about comparable. So it works only with comparable types, and we can do only equal or unequal. It doesn't allow us to do greater or smaller. For this, yeah, we can use it. Alrighty, now let's have a look how we can use generics inside of the structures. Before, we used mainly interfaces when we wanted to put inside of the structure whatever we want. But now with generics, we as well provide it with the type safety guarantee, and it's more recommended to use generics instead of empty interfaces. Let's have a look why. So let's assume that we would like to create a box to which we can put whatever we want, like banknotes, strings, etc. And we would like to reuse this logic. Alrighty, let's define the struct box. And inside of it, we'll have only one property, which is items. And items will be with type empty interface array. Okay, and we need a couple more methods to add and get items from the box. Okay, let's test it out now. Let's say we add banknotes first. Okay, and let's assume that we would like to convert them from one currency to another. Okay, gotta add here the type, but as you can see, as far as it's empty interface, I cannot directly perform multiplications here. I gotta cast first. Let's cast it to the int and check if it works as expected. As you can see, everything works as expected. But let's assume by some weird reason we added here some string. Let's see if it's gonna work. No, it doesn't. It returns panic. For sure, we can add some type safety checks with the comma issue, etc. But why do we need to do that, right? We have generics in place. Let's have a look how generics help us here with type safety checks. So inside of the struct, we can define the generic constraint with constraint any. If we go inside, it says us that it's basically an alias for interface, and it's equivalent to the empty interface. But I don't really agree with this, because except of providing empty interface, it also provides us safety check guarantee, and we'll have a look in a second into it. So let me fix it up. We're gonna use everywhere this type that we have created. Okay, and now here we need to specify the type with which we would like to work. Let's say I would like to work with integers. I would like to put only integers inside of the box. So, and as you can see here, immediately we're getting compilation error. So it doesn't allow us to work with strings over here because we specified integer type in the generic. Okay, so, and I don't need those casting either. I can straight away do multiplication. And let's comment this line and see if it works as expected. As you can see, it works as expected. Yeah, I think that's mostly it. As you can see, generics help us to prevent some type safety issues, and we can use it for any type. So if we would like to use string, we can use strings. Of course, we won't be able to do multiplications, but yeah, just wanted to show that now this box became kind of generic type, generic data structure, and we can use any types with it. Hope that makes sense and hope it was helpful. Okay, so as I promised, here's the quiz in the end of the video. Hope you learned something new, and now we're gonna test your knowledge. To make it more engaging, I would suggest to write down your answers to the comment section under this video, and let's jump straight to it. So the first question is, what is the primary benefit of using generics in Go? Option A, they allow functions and types to work with multiple types while maintaining type safety. Option B, they make Go code run faster at runtime. Option C, they remove the need for using interfaces in Go. Take your time, pause this video, and think about the answer a little bit. And ready, steady, go. I suppose you prepared your answer. The right answer is A. They allow functions and type to work with multiple types while maintaining type safety. Alrighty, let's move on to the next question. In Go, which of the following syntax represents a generic function that works with any type? Option A, I don't want to pronounce it. Option B, option C. Think about it for a little bit, pause the video, and again, I will provide you with the correct answer in a second. Ready, steady, go. I think you're ready. So the right answer is C. Yeah, we use generic constraints, T and any, the keyword, to create a generic type which will allow you to work with any types, basically. Cool, let's move to the next question. Consider the following code snippet. What will be the output? So what we can see here, simple function which doubles the received value, and it works with int and float 64. So it just does multiplication by 2. And we need to guess what's gonna be the output. Option A, 6 and 9. Option B, 6 and 9.0. And option C, compilation error. Again, pause the video, think about the answer a little bit, and I will provide you with the correct answer in a second. Ready, steady, go. Hope you come up with the answer. The correct answer is B, because here we use integer, so we're gonna double this integer value, and over here we use float, so therefore will be float result with this float ending. Alrighty, I hope it was fun and you answered to the questions correctly. If you have any questions for me regarding the quiz or anything that related to this lesson, feel free to ask them in comment section down below. Yeah, I hope it was useful.